Now we'll see how to solve a problem in quantum mechanics. The problem is a particle constrained to move along x-axis in the domain x lies between 0 to L has a wave function psi is equal to sin n pi x by L, where n is an integer. Find the normalization constant and evaluate the expectation value of its position. This problem I have taken it from quantum mechanics by R. Given that psi is equal to sin n pi x by L, now we have to normalize this wave function. If it is an normalized wave function, then it is integral from minus infinity to infinity, psi n star psi n dx is equal to 1. If it is the given function is a unnormalized one, so if you want to make it as a normalized one, then psi n is equal to 1 by n psi, where n is the normalization constant. Now we have to find out this normalization constant. So now you substitute this 2a in equation 2, then it becomes integral from minus infinity to infinity modulus of psi squared dx is equal to n squared. Now you substitute the value of psi, then it is integral from 0 to L sin squared n pi x by L x into dx. Here the sin squared can be written as 1 minus cos 2x by 2. So it is 1 by 2 integral from 0 to L into 1 minus cos 2 pi x n divided by L into dx. Now we have to integrate this. So if you integrate, then it is 1 by 2 x plus sin 2 n pi x by L divided by 2 n pi by L. Now you have to substitute the limit 0 to L, then it is the first term you can get L by 2 and the second term it is 0. So if you substitute this value, then it is n squared is equal to L by 2. So n is square root of L by 2. Now if you substitute this value, then it is the normalized wave function is square root of 2 by L sin n pi x by L. Now you have to find out the expectation value of position. So it is equal to integral from minus infinity to infinity psi n star x psi n dx. Now you substitute the value of psi n, then it is 2 by L integral from 0 to L x sin squared n pi x by L into dx. The sin squared can be written as 1 minus cos 2x by 2. So it is 2 by L integral from 0 to L x by 2 into 1 minus cos 2n pi by L into x into dx. Now if you integrate, first term it becomes x squared by 2, substitute the limit 0 to L. Second term it is the integral from 0 to L x cos 2n pi by L into x dx. Now for the first term you substitute the limit, and second term you integrate it by parts. So it is integral from 0 to L x cos 2n pi by L into x dx. Here you take it is of integral u dv formula. So u is x and dv is cos 2n pi x by L into dx. So du is dx and v is L by 2n pi sin 2n pi by L into x. So if you substitute this, then it is integral from 0 to L x cos 2n pi x by L x dx is uv. So it is Lx by 2n pi sin 2n pi by L into x, and you have to substitute the limit 0 to L, and integral uv minus integral v du. So it is integral 0 to L 2n pi sin 2n pi L x dx. So now if you integrate, substitute the limit for first term, then it is 0. For the second term, if you integrate, then it is L 2n pi integral from 0 to L sin 2n pi by L x dx is L divided by 2n pi L into 2n pi cos 2n pi x by L. Now you have to substitute the limit 0 to L, then this becomes 0. So only the first term you have. So the expectation value of the position is L by 2. Thank you.